Second important chapter is electrostatic potential and capacitance. In this chapter, the very important questions for board examination is first one is what is electric potential? It is important for 1 mark. Electric potential at a point in an electric field is the work done in bringing a unit positive charge from infinity to that point against the electric field. Another important question is 5 mark. Obtain the expression for electric potential due to a point charge. You must and should write diagram for derivation. You got full marks, otherwise cut 1 mark for diagram. In the figure, Q is a point charge placed at O in free space. X is the distance between Q and 1 coulomb. P is a point at a distance or from O. E is the electric field due to the charge Q plus 1 coulomb is the charge placed at a point A. A and B are the 2 points separated by a small distance. From Coulomb's law, F is equal to 1 by 4 pi epsilon Q by x square. This is equation 1. The work done in moving 1 coulomb of charge from A to B is dW is equal to minus F into dx because we are moving unit charge against electrostatic field. The total work done in moving 1 coulomb of charge from x is equal to infinity to x is equal to r can be calculated by using integration. W is equal to integration of infinity to r dw. W is equal to integration of infinity to r dw is minus F into dx. W is equal to integration of infinity to r minus where f is 1 by 4 pi epsilon naught q by x square into dx from equation 1. Then constant are taken out from integration. W is equal to minus q by 4 pi epsilon naught integration of infinity to r in 1 by x square into dx. The integration of 1 by x square into dx is minus 1 by x. That is W is equal to minus q by 4 pi epsilon naught into minus 1 by x. W is equal to apply limit infinity to r, upper limit minus lower limit, that is W is equal to q by 4 pi epsilon naught 1 by r minus 1 by infinity, that is W is equal to q by 4 pi epsilon naught r. This is equation 2. For a charge of 1 coulomb, work done is equal to electric potential, that is W is equal to V. Then V is equal to 1 by 4 pi epsilon naught q by r. Another important question is what is equipotential surface? This is important for 1 mark. Any surface which has the same electrostatic potential at every point is known as equipotential surface. Another important question is mention the properties of equipotential surface. Sometime ask 2 marks, sometime ask 3 marks. The first property is no two equipotential surfaces intersect. Second one is work done is 0 in moving at a test charge over an equipotential surface. Third property is the direction of electric field is always normal to the equipotential surface. The fourth point is equipotential surfaces are closer in the region of strong electric field and further in the region of weak electric field. And next, fifth property is equipotential surface gives a visual picture of both the direction and magnitude of electric field E in a region. You sometimes ask 2 marks in the examination, you just enter any 2 points. Sometimes ask 3 marks, and that time you must and should write 3 properties. Another important question is derive the relation between electric field and potential. This is important for 3 marks. Let E be the electric field due to the charge Q. A and B are the 2 points in the electric field. Dx is the small distance between A and B. Q0 is the unit positive charge placed at A. Let dV be the potential difference between A and B. dW be the work done in bringing Q0 from A to B. By definition, dV is equal to dW by Q0, as W is equal to force into displacement, that is dV is equal to minus F into dx divided by Q0. Negative sign indicates that field and displacement are in opposite direction, that is dV is equal to minus E into dx, because F by Q naught is equal to E. Therefore, E is equal to minus dV by dx. Therefore, electric field at a point is equal to the negative gradient of electrostatic potential at that point. Sometime asked in multiple choice question, only mention the relation between electric field and potential is E equal to minus dV by dx. This is important for 1 mark. Another important question is obtain the expression for capacitance of parallel plate capacitor. Consider parallel plate capacitor of a capacitance C as shown in the figure. Let D is the distance between plates of a parallel plate capacitor. Plate I is given positive charge plus Q, and plate second is given equal to negative charge minus Q. A is the area of each plate, E is the uniform electric field between the plates, V is the potential difference between the plates. Sigma and minus sigma are the surface charge densities on plate first and second respectively. We have capacitance is equal to charge by voltage, that is C is equal to Q by V. Equation 1. Electric field in between the plate is given by E equal to V by D. This is equation 2. And E is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught for two thin charged plates, that is E is equal to sigma by epsilon naught. This is equation 3. On comparing equation 2 and 3, we get V by D is equal to sigma by epsilon naught, that is V is equal to sigma D by epsilon naught. This is equation 4. Substituting equation 4 in equation 3, we get C is equal to Q epsilon naught by sigma D. This is equation 5. But sigma is equal to Q by A, that is Q is equal to sigma into. Therefore, equation 5 becomes C is equal to sigma A divided by sigma D. That is C is equal to epsilon naught A divided by D. Another important question is obtain the equation for capacitance of two capacitors connected in series. This is important for 3 marks. Sometimes this expression is important for solving the problems. In the figure, A and B are two capacitors connected in series. C1 and C2 are capacitances of A and B respectively. V1, V2 are potential differences across A and B respectively. V is the potential difference applied across the combination. Q be the charge on each capacitor. In the series combination, V is equal to V1 plus V2. Equation 1. We have V1 is equal to Q by C1 and V2 is equal to Q by C2. The equation 1 becomes V equal to Q by C2 plus Q by C1. Therefore, V is equal to Q into 1 by C1 plus 1 by C2. This is equation 2. If the combination is replaced by the equivalent capacitor of capacitance CS, we get V equal to Q by CS. This is equation 3. On comparing equation 2 and 3, we get Q by CS is equal to Q into 1 by C1 plus 1 by C2. Therefore, 1 by CS is equal to 1 by C1 plus 1 by C2. Take the LCM, then CS is equal to C1 plus C1 by C2 divided by C1 plus C2. Another important question is obtain the equation for capacitance of two capacitors connected in parallel. This is important for 3 mark. In the figure, A and B are two capacitors connected in parallel. C1 and C2 are the capacitances of A and B respectively. Q1 and Q2 are the charges on A and B respectively. V is the potential difference applied across the combination. From parallel combination, Q is equal to Q1 plus Q2. This is equation 1. We have Q1 is equal to C1 into V and Q2 is equal to C2 into V. Equation 1 becomes Q is equal to C1V plus C2V. Q is equal to V into C1 plus C2. This is equation 2. If the combination is replaced by the equivalent capacitor of capacitance CP, we get Q is equal to CP into V. This is equation 3. And comparing equation 2 and 3, we get CP into V is equal to V into C1 plus C2. That is CP is equal to C1 plus C2. Another important question is derive the expression for energy stored in a capacitor. This is important for 3 mark. When a battery is connected across the uncharged capacitor, the charge transfers from one plate to another plate, bit by bit in small amount dq. Consider an intermediate situation when charges on plate are q and minus q. At this stage, potential difference between the plate is V dash is equal to Q by C. This is equation 1 where C is the capacitance of the capacitor. Let dq be the extra charge transferred in the capacitor such that V dash remain constant. The work done in transferring charge dq is given by dw is equal to V dash into dq. This is equation 2. Substituting equation 1 into we get dw is equal to q by c into dq. This is equation 3. The work done in transferring charge from q is equal to 0 to q is equal to capital Q is given by w is equal to integration of 0 to q dw. This is equation 4. Substituting equation 3 in 4 we get w is equal to integration of 0 to q by c into dq where constant is taken out of from integration sign. W is equal to 1 by c into integration of 0 to q into dq. The integration of q into dq is q square by 2. That is W is equal to 1 by c into q square by 2 limit 0 to q. Next apply limit up. First apply upper limit and then apply lower limit. W is equal to 1 by c into q square by 2 minus 0 by 2. That is W is equal to q square by 2c. This work done is stored in capacitor as electric potential energy. That is U is equal to q square by 2c. Sometimes ask in multiple choice question only mention the expression. The energy stored in the capacitor is U is equal to q square by 2c.